So for this example, we're going to continue with using inductive reasoning. And this example says, bacteria and other microorganisms can multiply at an alarming rate. Suppose a particular bacteria culture contained in a petri dish starts an initial growth with a single bacteria. If the bacteria doubles every hour, how many bacteria would there be after 1 day? Now, certainly the point of this chapter is to think clearly and logically. So as we read word problems, we must make sure we know exactly what we need to answer the problem. So as I go over this, let me just point out a couple of things here. It says bacteria and other microorganisms can multiply at an alarming rate. So what is an alarming rate? Well, to me, that seems like something that'll be very fast. So whatever we start with, by the time we end, it's going to be something that's probably going to grow very quickly. Then it says, suppose a particular bacteria culture contained in a petri dish starts an initial growth. Here we have an initial growth with a single bacteria. So at the start, at the beginning, we only have one bacteria. Then it says, if the bacteria doubles every hour, what does that mean? Well, I guess we just multiply it by 2. Whatever the current bacteria count is, by the time the next hour goes by, we just multiply it by 2. So then how many bacteria would there be after 1 day? In 1 day, that's 24 hours, right? So here we have this petri dish, and I'm just going to draw a quick picture here. And a petri dish is just these plastic dishes that the chemists and biologists have. They grow microorganisms and cultures inside of them. So you can imagine there is a bacterium that starts off right there. And then after an hour goes by, it doubles. So we have 2 of them. After another hour goes by, it doubles again. We then have 4. Then when an hour goes by, this doubles again. We then have 8. So I think I get the idea, or we get the idea as far as what's occurring. So what I'm going to do is I'm going to make a table to help organize my thoughts. And you should too. You should do whatever you need to do to give yourself a clear understanding of what is occurring. So I'm going to start a table here. I'm going to put down maybe hours. And then over here, maybe the number of bacteria. So of course, at the start, we have 1 bacteria. So the hours is, no hours have gone by. That's our initial growth. We start right there. Our initial means at the beginning, we have 1 bacteria. Then after an hour, we have 2 bacteria. And of course, that's this right here. Another hour goes by, we now have 4 bacteria. And of course, this is this right here. Another hour goes by, 8 bacteria. 4 hours, 16, 5 hours, 32. So now we've established this pattern, and very visual. We can see what's going on. We used a picture to help give us an idea of what's occurring, and then of course we start writing down, gathering our thoughts as far as this pattern that's developing. Now, if it said after 10 hours, we could probably just continue this. 6 hours, that would be 64. 7 hours, that would be 128. And we could just do that a few more times and come up with, if it was 10 hours. But this is 24 hours. So I'm just going to go ahead and establish a pattern here. We know that 2 here, we take the first start, the initial growth here, and multiply it by 2. So this obviously is 1 times 2. We just double this here. 4, what's that? Well, we double this here. What's 2? Well, that's 1 times 2. And then we double it times 2. 8, well, that's 4. That's 1 times 2 times 2. But then we double it times 2. 16, well, that's 8. That's 1 times 2 times 2 times 2. But then we double it again. And of course, we could see a pattern developing again. 32, that's 16. 1 times 2 times 2 times 2 times 2. And then we double it again. And of course, this pattern would continue. Another way of writing 2, that's 2 to the first power. Another way of writing 4, well, that's 2 times 2, or in other words, 2 to the second power. Another way of writing 8, that's 2 times 2 times 2, 2 to the third power. And again, we have this pattern again. This would be 2 to the fourth, 2 to the fifth. And up here, I'm going to say 2 to the 0 power. Anything to the 0 power always equals 1. So now as we look at the powers here, I've got 0, 1, 2, 3, 4, 5, and those powers match the hours that went by. So we could imagine that if this pattern were to continue, we were to go like this, then I guess we could say after 24 hours, that would be 2 to the 24th power. Then, of course, we can use our calculator at this point. And 2 to the 24th power, that's 16,777,216 bacteria. So you start off with 1, you come back a day later and you have almost 17 million. So that does seem like it's an alarming rate as far as I'm concerned. But notice what I did. We went ahead and I drew a picture here to give me an understanding of what's going on. I organized my thoughts using a table. And you don't have to use a table, but you should do something to be able to collect what's going on, to be able to take this word problem and put it into a nice, clear explanation of what it is that you need to do. But there we go.